Good afternoon to you all. This presentation, we're not trying to put it out there as a hard sell. It's hopefully an informative session that people will get something out of. Setting the scene for today, we're going to talk about asset management definitions. What are assets to our customers, and where does the production fit into asset management? We have the good, the bad, and the ugly. Maintenance contracts being a good point, seems to work pretty well for a lot of companies. Transformer oil leaks is something that we don't want on site. Power equipment failures, they can be very, very untimely. It's normally of a Friday afternoon, 2, 3 o'clock, when something happens. And we need to get a team together to get out and help the customers. I've put in a couple of case studies of events that have happened over the past couple of years, which hopefully you'll get some information out of. What is the definition of asset management? Straight from good old Google, asset management refers to a systematic approach to the governance and realization of value from the things that a group or entity is responsible for over their whole life cycles. It may apply both to tangible assets, being physical objects such as buildings or equipment, and to intangible assets such as human capital, intellectual property, goodwill, or financial assets. With regards to infrastructure asset management, this is the combination of management, financial, economic, engineering, and other practices applied to physical assets with the objective of providing the best value level of service for the costs involved. It includes the management of the entire life cycle, including design, construction, commissioning, operating, maintaining, repairing, modifying, replacing, and decommissioning, disposal of physical and infrastructure assets. Operation and maintenance of assets in a constrained budget environment require a prioritisation scheme. What are assets to our customers? Some of you may know the history of Ampcontrol, which was previously known as Railic Engineering. Back then, we were a supplier to the coal mining and metalliferous mining sectors, being in the 70s and the 80s. It was not unusual to be building 15 underground substations or transformers for Elcom or 25 underground substations for Newcom. Coal production was booming and customers required more supply equipment to get out of the ground. The Ampcontrol of today has expanded into a variety of work environments. While some of that original equipment is still in use, newer and more modern equipment is now available and in service, giving customers a greater confidence in their assets. Workshop structure and services have greatly improved, which has led to a greater efficiency in the construction, manufacturing, and maintenance of critical equipment. With regards to just a bit of a sidetrack on that kickoff of Railic Engineering, there used to be quite a number of mobile substations on Caterpillar tracks or wheels, and 5 MVA to 20 MVA. While the switches and circuit breakers in these, the majority of the steel work was fashioned here at Tomago. For the late 70s, early 80s, the Railic Engineering workshop was a different beast. The sheet metal workshop was at the front of the workshop, the painters were in the middle, and the electricians were down the back on a dirt floor. But even back then, there was a pride and professionalism in the equipment that went out the door. The work conditions did not stop us from producing belt starters, correction units, section isolators, section circuit breakers, and numerous underground and above ground substations and switch rooms. With more specialised equipment being manufactured, we realised that there was a real need for an installation and maintenance service to look after our customers' assets. Enter Railic Engineering Services. We now needed to be able to convince our customers that all electrical equipment especially in the harsh mining game, needs to have some sort of ongoing and or preventative maintenance to ensure it sees out its entire life cycle. What are assets to our customers? Knowing what a substation, knowing that a substation or switch room or a ring main unit or transformer has been supplied and installed to a high level of commitment allows for confidence in continued production supply. Add to this a regular maintenance program, or by putting a service contract in place, can also add to the confidence of the customer. Any equipment that is part of a production program needs to be able to be relied upon, especially in a constrained budget environment. Some prioritisation would be required in this instance, of course. Having knowledge of their assets through reporting or through training can be beneficial to increased awareness of the status of those assets. Where does production fit into asset management? Mechanical people want to see the conveyor moving or the drag line swinging or the product stacked up on the pad or on the shelves, but it cannot get there or be retrieved from the storage pad or shelf if the equipment used to do that job breaks down. Electrical switch yards that bring power to the site, the transformers that lower or step up the power for the site requirements, the switchboards and switch rooms that receive and distribute power, and the end equipment that digs it or moves it, lifts it or carries it or stacks it, all have components that require maintenance. Production people might see a square box with electrical cables in and out, not a priority piece of production equipment. Electrical people see a power transformer, HV in, LV out, and it keeps all the wheels and of course the machine that goes ping moving. Electrical circuit breakers and isolators and contactors and transformers, and the list goes on. They all have their part to play in both production and of course safety. Will that switch open or trip if overloaded, or worse, if there is a failure? Does that RMU have enough gas in it to do its arc quenching job? Will the overhead air brake switch open when it needs to isolate or close properly at the end of the day? Increased use nowadays of monitoring and asset management portals has been a vast improvement in both preventative and ongoing maintenance. The circle of monitoring and documentation, as well as the planned maintenance, can now give companies increased confidence in their assets. Confidence in assets means confidence in production. A large number of sites are using work order type documents to plan maintenance and have that maintenance carried out. Reports we supply from that site work can be the basis of planned work. What role does field service play in asset management? We've put up there a bit of a list of some of the activities that we do on a day-to-day basis locally throughout New South Wales and throughout Australia. High voltage switchyard maintenance, being bushing testing, switchgear maintenance, oil sampling, the power transformer maintenance, oil filtering, upgrade work, high voltage switch room maintenance. These can be the isolators and circuit breaker testing and inspection on cable terminations. Ring main unit maintenance, checking the operation of the RMU, doing insulation, ductor and protection checks on the switches, making sure everything works. Transformer and switchyard testing. Here we do the winding ratio, polarizing index. We can do bushing tan delta, insulation or trip function checks. Protection relay testing is a big one with the modern relays in place now. There can be current transformer testing, again trip function checks and relay parameter proving. With high voltage cable testing, these can be on XLPE cables or your good old paper leads or your newer EPR type, as well as rubber cables used extensively through metalliferous mining situations. Can also include insulation test, being ACVLF, which are pretty common nowadays, or DC test plus tan delta testing. Buried services locator is something that we occasionally do. Site services for upgrade work, possibly for public utilities, if they want to do improvement work, or doing fault location work. high voltage cable terminations and jointing, gas insulated switchgear using your Pfister type plugins, ring main units, screened elbows, underground to overhead cables, repairs on cables, swap out, and lately a lot of wind and solar farm work. Transformer oil purification, regeneration and supply. We can do retro fills, vacuum filling, oil transportation, offline or online filtering, or supply of generated oil. Some good examples of good asset management: regular inspections of oil levels on power transformers, oil leak repairs on transformer, and regular oil sampling, testing of transformers, testing of ring main units, program protection relay testing, continuity, ductor and earth testing of switch yards and switch room equipment, power cable testing, buried services scanning, thermal camera and visual inspections of overhead power lines, cross arms and air brake switches. A couple of the photos that we have up there. We have some topping up of transformers, which is quite common. If there's a lot of leaks on the transformer, then your oil level will drop. And as we all know, it can be affected by the temperature. If it's a cold day, the oil will contract, which can cause tripping. Second one there to the side is some high voltage testing on 33 kV switchboards. Next one down is some basic testing on a transformer. For those of you older engineers and people out there, in that situation we had to remove the Sefton gel from a transformer switchboard box and replace it with a new cable and turn it into an air box. Bottom left is basically some high voltage switchgear on a 33 kV circuit breaker. So maintenance and inspection on the contact points inside that breaker. And the last one in the bottom right is the oil filtering machine. So we're filtering oil on site and then topping up the transformers. Just to sidetrack again for a moment, with low oil levels, they can cause trip when the temperature drops. Oil leaks have both an environmental and operational impact. Regular oil sampling can give quite a large overview of what is happening inside that big grey box. Simple, basic insulation and polarizing index tests are very beneficial to give you an indication without opening up the transformer. The PI test is a big one we use, and it can provide information on the moisture and deterioration of the winding insulation. Test being a 10-minute to 1-minute ratio, an acceptable value being at least 2 or higher. If we end up with values between 2 and 1, could indicate a marginal condition, or values below 1 could indicate a poor condition. In switch yards, we have continuity of all earthing, lubrication of the ABS and earth switches, cleaning of the insulators, testing of power factor capacitors and reactors. All of these add up to a peace of mind. With as found high voltage cables or upgrades and replacement of high voltage switchboards, cable testing first can give you a footprint of that cable under test. It can then be documented, and the deterioration in that power system can be flagged. In buried services scanning, a customer may be looking at extending a switch room or a switch yard and needs to know what's in the ground. Thermal cameras have come a long way, and a simple drive-by of your private overhead network can pick up loose connections, burnt contacts, tracking on wooden cross arms. When carrying out all of these services, the resultant condition report can then offer up recommended maintenance or replacement of suspect or end-of-life equipment. Back onto the screen, we have here some examples of bad asset management. Running through the list, oil leaks on power transformer, again as mentioned, an environmental issue. Transformer silica gel breathers saturated, so when the colour changes, it means it's not doing their job. Damaged high voltage cable terminations, mismatched termination kits on high voltage cables, over-tightened rear insulating plugs on screened elbow terminations, which is one of our case studies today, irregular protection relay testing, failure to test the protection system after an upgrade, low oil level in power transformers, or not conducting oil sampling of power transformers or conveyor magnets or oil-filled circuit breakers. Big issues we see on site are oil stains as opposed to oil leaks. It does not take a lot of oil, especially on a coal mine site, for a big black stain to cover a transformer. With older transformers, the type of gasket cord used was not that flexible. With aging, it becomes hard. Present corks are more of a nitrile rubber mix and offer way more flexibility for expansion and contraction. A simple maintenance procedure is to go around and nip up the lid bolts, the Buchholz bolts and the collars on the valve handles. With silica gel breathers, the design has changed and improved over the years, with many of the smaller Coke bottle types not having an oil bath anymore. With regards to all high voltage terminations, these require an air gap between phases and phases to earth, and also in the case of parallel cores, which are both bolted onto the same phase. Adding an insulation material between the power cores and a frame or support only makes that situation worse. And again, that will be shown later on with one of our case studies. We come across a lot of 600-volt PVC tape wrapped around a power core termination as the phase color ID. All high voltage terminations have leakage on them. To stop or interrupt that leakage by the application of tapes can have long-term failure issues. Going on to the photos that we've got up there on the screen. As mentioned, a transformer, fairly badly stained. It may only be a minor leak that's possibly a lid bolt that's come loose or around the sight glass. Could even be where the temperature indicator has been put into the transformer and may not be tight enough. Next photo on the top right shows how badly the tracking can be across a PVC tape that's been put onto an 11,000 volt cable. So while it indicates what phase that is, right, not the best way to go. That's an extreme condition, and it was caused by very high humidity in the location where it was. The bottom left photo, again, is where there is a lack of clearance between your phases, and you can see corona that's been produced on that cable. Excuse me. The last one there is indicating a low oil in a sight glass on a transformer. Where that photo came from was on a site where the transformer was used to supply pumps. What was happening there was that the oil level during cold days, the oil level would drop, would drain out of the Buchholz protection relay and cause the transformer to trip. All that was needed there, once we found out that's what it was basically a top up of the oil. Move on now to a couple of the case studies. Okay, at a coal mine, we had unidentified trips on 11 kV stacker machine. Customer noted that one of their stacker machines was intermittently stopping during its operation. A possible cause initially thought was the operation of an earth leakage protection relay, which when tested in service was found to be functionally correct. During the tripping investigation, it was noticed that there was evidence of corona between phases on the power cores inside the onboard slip rings. The termination kit on the slip rings cable was removed, which exposed multiple examples of what I would deem very poor workmanship in the preparation of the Protolon rubber power cable cores. The damaged cores were stripped of the as-found termination components. The power cores sanded to remove the as-found damage, and a new heat shrink termination kit fitted to the cable. To date, there have been no more further unidentified trips. The next slide, we have some of the photos from that site. What you can see here is that site have thought that, okay, there may be an issue with the high voltage causing some sort of spike through the control cable. So they've applied a piece of PVC insulation and then wrapped it in 23 tape. Excuse me. What that has done has decreased the air clearance between your phases and actually to the control cores. The second slide there shows where the control core on the bottom and the power core, where they've both been, shall we say, insulated to try and rectify the problem. But as mentioned, all it's done is decrease the air gap between the power core and that control core. Top right hand side, we've taken off the red high voltage tubing from the original termination kit and discovered that underneath, instead of finding the bare rubber core, we've found the core wrapped up in 23 tape. The bottom one is actually what the rubber core looked like once that 23 tape had been removed. Fairly evident that when the semicon was removed off that core, it's basically torn a heap of insulation off that power core. Right. All these little indents, the hollows, the peaks are all points of high stress. Before we move on to the next one, to rectify that situation, what we did is we sanded back the power core, which smoothed out all those hills and bumps and hollows that were in there. Refitted a correct termination kit, put the termination back in service, and to date we've had no more instances of any unidentified or intermittent tripping. Moving on to our second second case study. This one's a common one that we find, a ring main unit maintenance, and the rear insulating plugs have been over tightened. Just excuse me for a second. Apologies for that. There are a number of brands of RMUs on the market. RMUs being a generic term, as some units are not connected in a ring main configuration. But basically, you've got a cable coming in and a cable coming out. High voltage maintenance on these units, being primarily insulation and ductor tests across the switches and earth switches, requires that the cable terminations be removed so that we can access the actual connection bushings and get our test equipment onto them. Where screened elbows have been used to terminate and connect the incoming and outgoing cables, we constantly find that the rear capacitive insulation plug, the RIP as we call it, has been over tightened onto the bushing cable connection stud. Additionally, we find that the minimum silicon lubricating grease that is supplied as part of the insulation kit has not been correctly applied during the assembly. This also adds to the tightness of the RIP. Unfortunately, when attempting to undo these plugs, they crack, or in the worst scenario, they break. This then requires them to be removed, the bushing studs replaced, and the new RIPs installed as per manufacturer's instructions. Just to sidetrack a little, as this situation is common during high voltage maintenance on sites, we have developed a procedure to replace the broken rear insulating plugs. If it's found on site and we attempt to undo the plugs, or if there's several plugs, after discussion with the customer, we may be able to replace the faulty plugs depending on the brand and if we have spares for that brand of RIP. If not, what we need to do then is we will need to obtain replacement parts and return at a mutually suitable time to complete the repairs. Moving to the next slide, basically we're just going through there the process of what we find on site. The first photo, what we tried to do there is use a screwdriver to open up the space between the rear insulating plug and the screened elbow and try and get some lubricant in there, hoping that that's all it was, that they weren't over tightened. Second slide there, you can see we've tried to undo it. It hasn't gone. Unfortunately, it's basically broken. When we tried the other two, same result with those. They broke off as well. As part of our process to repair them, we need to drill them out so that we can get a tool into there and undo the broken RIP. Bottom photo there in the middle showing that we've got the RIPs out. Unfortunately, there's been some damage to the connecting pin, which is just shown in there. So they need to be replaced as well. The final photo there is basically the broken RIPs have been removed and new ones replaced on the screened elbows so they can go back into service. Our last case study for the day was a paper processing plant where we replaced a power transformer. On site, they had an expansion of services, and with that expansion, they required an upgrade in the output of their power transformer. On older sites, for example in Sydney, the design of the transformers in service can be quite old. An older 750 kVA, 11 kV to 433 volt transformer on site could be the same as a modern 2.5 MVA transformer. On the site in this case study, we removed the 1.5 MVA transformer and replaced it with a 2.5 MVA. We find that a lot of these older transformers use paper insulated lead covered steel wire armoured cables. These have their own requirements, of course, to connect to the newer transformers with regards to the bushing types that are used, the access and getting onto the transformers. For the low voltage cables, it is not uncommon to have 3 or 4 cores per phase and be 300 or 400 square mil in the cable size. Again, that presents its own little issues when you're trying to connect things back up. With attention paid to preparation, pre-site shutdowns, site inspection, and with plenty of communication with the customer, these upgrades or the replacement type of jobs are able to give peace of mind to the customer in their new asset and with regards to future production. Running through some photos for site for that case study. That's the original transformer. As you can see, it's quite high and fairly well packed into the location. This is the as found cable. Initially, it was assumed to be paper lead, but it turned out to be an XLPE cable. On the low voltage side of things, we had 300 square mils per phase. So again, fairly difficult to work with. The last photo on the top there was the existing 300 square mil cables coming in and up to the transformer. We had to do a little bit of modification to get them to suit the new transformer. First photo on the bottom left is some supports, as the existing concrete pad for the older transformer was not quite large enough to take the new footprint. So some support beams were used, and under those support beams, you can see the pink pads there. They were anti-vibration pads. The new transformer, while being lower than the original, was a little bit wider due to the cooling fins on it. Second last photo there being the XLPE cable. So there were modifications required to get the lead, to get the cone off it. That actually reused the lead watt cone on there. So that termination was modified so that it could suit the new cable bushings. Last photo there on the right is the new transformer installed and ready for service. What does the future hold for asset management? The use of online portals to monitor operations and/or repairs. Benefits including viewing of both static and live data, for example, test reports, current readings, and the like. To help asset managers make informed asset management decisions, all these options can be available. For program maintenance on critical assets, this may include periodic or annual reviews of your critical assets on site. We would recommend looking at a 3-year maintenance schedule with your service provider. This ensures continuity of asset management and monitoring of any concerns over a scheduled period. Examples can include annual transformer oil sampling and review of results and the data that's required from those sampling. Protection relay testing is another one, and grading performance confirmation, basic, premium or high-end transformer testing. Ensuring a service provider has on-call availability for breakdowns, fault location and equipment race replacement capabilities. I would like to thank you all for your attendance today, be it in the virtual world. If you have any questions, we can now look at going through those. And from Ampcontrol and myself, the high voltage field service and our sister underground field service, I'd like to thank you all for today.